Welcome to the video on rates. Here's today's objective. I will be able to define and identify rates. You're already familiar with ratios. Remember, we put this in our mathematicians' notebooks. A ratio shows the relationship between two groups. And a ratio is a way of comparing. So in one of the examples we talked about, here are two circles and three triangles, and so the ratio of circles to triangles is 2 to 3. And one way of understanding that is for every 2 circles there are 3 triangles. Here's another example. The ratio of penguins to bears is 3 to 2. And that means for every 3 penguins there are 2 bears. Now the ratio is, I've got 6 penguins to 4 bears, but that's still 3 to 2, because for every group of 3 penguins, there are 2 bears. And even if we add some more penguins, so now there are 9 penguins, and some more bears, there are 6 bears, the ratio is still 3 to 2, because for every group of 3 penguins, we've got 2 bears. When we talk about ratios, we're usually talking about comparing the same kind of thing. So here we're comparing penguins and polar bears, and both of these are animals, so we would just talk about the ratio of penguins to polar bears. But if I want to compare different kinds of things, like penguins and these lovely ice islands that they're on, I have to use a rate. A rate is a type of ratio that compares two different kinds of things. So here, I would say the rate of penguins to islands is, well, there are 6 penguins for every 2 islands, and I can simplify that to 3 penguins for every 1 island. The rate is 3 to 1, 3 penguins per 1 island. Here's another example of a rate. If you're driving on the road and you see a sign like this, it means that's the fastest you can drive your car without the police coming after you. And we would read this as 50 miles per hour. That's a rate. It says that you can go 50 miles in 1 hour. That's the fastest that you can go. You may have heard that word per that I just said and wrote. The word per means for every. Just like when we're talking about ratios, we're talking about for every. So if I have a rate of the cost per Snickers bar, Mars bar, like $3 per 2 Mars bars, then really what I'm talking about is it costs $3 for every 2 Mars bars that I want to buy. Here's another example of a rate. This car is traveling at a speed of 55 miles per hour. And you may notice that there's no number after the word per. And that's because when we just write per hour, we're talking about per 1 hour. So when you don't see a number after the per, it usually means we're talking about 1. This car is traveling 55 miles in 1 hour. Here's one more example. A lot of DJs talk about the beats per minute of a song. That's the number of beats that's in 1 minute. And of course, we know 1 because we're talking about per minute, per 1 minute. So this cat is DJing at a rate of 120 beats per 1 minute. Alright, so I want you to copy these notes into your mathematician's notebook. A rate is a ratio that compares two different things. Rates usually use the word per, which means for every. And here are a couple more examples of rates. $10 per apple, per 2 apples, 55 miles per hour, and sometimes we write mph for miles per hour, and 80 beats per minute. And 80 beats per minute is about the average rate of a human heart. So your heart is probably beating right now somewhere around 80 beats per minute. If you need to pause the video to continue copying this, please do. And also remember to put this in your index under R for rates. Because rates are just a special type of ratio, we can use all the tricks we have with ratios to solve rate problems. So here's a problem. It costs $3 per burger at a restaurant. How many burgers can you buy for $27? To solve this, just like with ratios, I'm going to start with a ratio box, a rate box here. And in my rate box, I'm going to put the dollars for burgers, so that's my guide. And then I can extend this table out and write some equivalent ratios. So I already know it costs $3 for one burger, and that's because the per burger means per one. That's my first ratio, and if I have the next two burgers, that's going to cost another $3, so 6. And of course you notice a pattern. This one's counting by threes, the dollars is counting by threes, and the burgers is counting by ones. So $9 gets us 3 burgers, and we can keep going with that as long as we want. Here's $12 gets us 4 burgers. But mathematicians like to use multiplication to solve rate problems because I don't want to count all the way out to $27. Instead, I want to say, you know what? I need to get to $27, and I have to figure out how am I going to get from $3 to $27. And whatever I do there, I'm going to do down here. Oh, I can just multiply 3 times 9. That gets me 27, which means if I multiply here, 1 times 9, that's 9. So my answer is 9 burgers. I can buy 9 burgers for $27. Here's another example of a rate problem. The school bus travels 3 miles in 5 minutes, and your home is 12 miles away. How long is it going to take to get you home? I'm going to use a vertical rate table this time. So we already know that the bus travels 3 miles in 5 minutes. And then after another 5 minutes, it'll go another 3 miles. So it's gone now 6 miles in 10 minutes. And then after another 5 minutes, it will go another 3 miles. So it's gone a total of 9 miles, and that's been 15 minutes for another 5 minutes. And then up the last 3 miles it goes. Next here. Last 3 miles, and it's home. So it's gone a total of 12 miles in 20 minutes. And that's what you can see right here. Here's 3, 6, 9, 12. And that's of course what we recorded in the table. And just like with the other problem, if we wanted to, we could go directly from 3 miles to 12 miles by multiplying by 4. And you'll notice that we have 4 groups of 3, so that makes sense. And if we multiply the miles by 4, we've got to also do that to the other side, to the minutes. We're going to multiply that by 4. And 5 times 4 is 20. So the answer is 20 minutes. And now you know some stuff about rates. Isn't that swell?